Hello, curious minds! Welcome back to Solar System's Wonders. Today we're venturing into the world of Saturn, the jewel of our solar system. Famous for its mesmerizing rings and enigmatic moons, Saturn holds secrets that go far beyond its stunning appearance. From powerful storms that rage for centuries to moons that might harbor life, there's so much more to this giant than meets the eye. Get ready to explore the wonders of Saturn like never before. Before we dive into the wonders of Saturn, let's start with some basic facts that make this gas giant so extraordinary. Saturn is the sixth planet from the Sun, orbiting at an average distance of about 1.4 billion kilometers, or 886 million miles. That's nearly 10 times farther from the Sun than Earth. Because of this vast distance, Saturn takes approximately 29.5 Earth years to complete just one orbit around the Sun. But that's not the only thing that sets Saturn apart. With a diameter of about 120,000 kilometers, more than 9 times that of Earth, it is the second largest planet in our solar system. You could fit over 700 Earths inside Saturn. Despite its size, Saturn is surprisingly lightweight. It's the least dense planet in our solar system. If you could find a bathtub big enough, Saturn would actually float on water, thanks to its low density. Saturn spins incredibly fast, completing a rotation in just over 10 hours. This rapid spin causes the planet to flatten at the poles and bulge at the equator, giving Saturn a slightly squashed appearance, what scientists call an oblate shape. With an average temperature of minus 177.78 degrees Celsius or minus 288 degrees Fahrenheit, our ringed planet is very cold. Saturn's story begins 4.5 billion years ago in the chaotic nebula that birthed our solar system. Imagine a vast cloud of gas and dust, remnants of ancient stars, swirling and colliding under the force of gravity. Within this cosmic dance floor, tiny particles began to clump together, drawn to each other like moths to a flame. Over eons, these clumps grew larger, their gravitational pull intensifying, attracting even more gas and dust. Composed primarily of hydrogen and helium, Saturn began to grow rapidly as its core attracted vast amounts of these gases, forming the massive planet we see today. Through a process known as core accretion, where solid material builds up a core that eventually becomes massive enough to attract large amounts of gas, or possibly through disk instability, Saturn started to dominate its region of the solar system. Its gravitational influence sculpted the space around it, herding smaller particles into its orbit. These particles, remnants of the nebula's building blocks, would eventually coalesce to form Saturn's magnificent rings, a celestial halo marking the planet's ancient origins. As Saturn continued to grow, its internal structure began to take shape, laying the foundation for the planet's complex layers and dynamic atmosphere that we see today. Saturn is a gas giant, which means it lacks a solid surface like Earth. Instead, it's a layered cocktail of swirling gases, primarily hydrogen and helium, with trace amounts of other elements. These layers are not static, they're in constant motion, driven by the planet's rapid rotation and internal heat. As you descend through Saturn's atmosphere, the pressure and temperature increase dramatically. The uppermost layer is a hazy realm of ammonia ice clouds, responsible for Saturn's pale yellow hue. Deeper down, you'd encounter layers of ammonium hydrosulfide and water ice clouds, creating colorful bands and swirls in the atmosphere. These atmospheric layers act as a giant weather system, generating powerful storms, some raging for centuries, a testament to the immense energy within this gas giant. As we descend even deeper, beyond the colorful cloud layers, we approach the heart of Saturn, its core. Here, the atmosphere gives way to the planet's inner secrets. Beneath the cloud layers, the pressure becomes so intense that hydrogen exists in a metallic state, where it behaves like a liquid metal. This metallic hydrogen layer surrounds the core and is a key player in generating Saturn's powerful magnetic field. Think of it like a massive dynamo, with the core as the spinning rotor. Scientists believe this core to be a dense sphere composed mostly of rock and ice about the size of Earth or slightly larger. It's a place of extreme conditions where temperatures can soar to over 11,000 degrees Celsius or 20,000 degrees Fahrenheit, hotter than the surface of the Sun. The exact composition and size of Saturn's core remain a subject of ongoing scientific investigation. Some theories suggest it might be a solid rocky mass, while others propose a more exotic state, a fuzzy core where rock and metallic hydrogen mix and swirl. Imagine a place where the familiar laws of physics bend under unimaginable pressure. Saturn's magnetic field is both vast and powerful, extending far into space to create a magnetosphere that dwarfs the planet itself. In fact, Saturn's magnetosphere is the second largest in the solar system, only surpassed by Jupiter's. This magnetic bubble extends more than 1 million kilometers from the planet in some directions, enveloping many of Saturn's moons within its protective shield. The magnetosphere is filled with charged particles, primarily protons and electrons, captured from the solar wind and the volcanic eruptions on Saturn's moon Enceladus. These charged particles spiral along magnetic field lines, creating intense radiation belts similar to Earth's Van Allen belts, but much larger and more powerful. The interaction of the magnetic field with the solar wind also generates stunning auroras at Saturn's poles, similar to the northern and southern lights on Earth, but on a much grander scale. This magnetic field, generated by the movement of electrically conductive fluids within Saturn, deflects harmful solar wind, protecting Saturn's moons from intense solar radiation. Saturn's rings are its most recognizable feature, a celestial halo that has captivated astronomers for centuries. These rings aren't solid structures but a vast collection of icy particles ranging from tiny dust grains to massive boulders. Imagine a cosmic disco ball, reflecting sunlight from billions of pieces. These particles thought to be remnants of comets, asteroids, or shattered moons, offering a glimpse into the ancient history of our solar system. The rings are incredibly thin, spanning hundreds of thousands of kilometers, but only a few meters thick. These rings are divided into distinct bands, each with its own unique characteristics. The main rings, A, B, and C, are the most prominent, with the A ring being the outermost, separated from the B ring by the Cassini division. This gap isn't empty though, it's populated by fainter ringlets and small moons. The B ring is the brightest and most massive, reflecting sunlight like a celestial mirror. Beyond these, Saturn hosts additional fainter rings, D, E, F, and G, that were more recently discovered. These outer rings are more delicate and diffuse, with some, like the F ring, being twisted and braided by the gravitational influence of nearby moons. These rings are far from static. They're a dynamic and ever-changing system, with particles constantly colliding, being pulled by gravity, and interacting with the planet's magnetic field. The ring particles aren't all moving at the same speed. Those closer to Saturn orbit faster than those farther out, just like planets orbiting the Sun. This difference in orbital speed contributes to the ring's intricate structure, creating waves and patterns as particles interact. The rings are also tilted relative to Saturn's orbit around the Sun. This tilt means that from Earth's perspective, the rings appear to open and close over time, like an eye blinking at us across the vastness of space. This tilt, combined with the planet's axial tilt, means we see the rings at different angles throughout Saturn's 29.5-year orbit. Saturn's rings aren't just subject to the whims of gravity. They're also sculpted and maintained by a cast of supporting characters, the shepherd moons. These small moons, embedded within or orbiting near the rings, exert their own gravitational influence on the ring particles, acting as cosmic sheepdogs. Some shepherd moons, like Prometheus and Pandora, orbit on either side of a narrow ring, their gravity keeping the ring particles confined, preventing them from spreading out. Other shepherd moons, like Pan, create gaps within the rings, clearing paths as they orbit, their gravitational influence carving out lanes in the icy debris. These shepherd moons, guardians of the rings, play a critical role in shaping and preserving these celestial wonders, ensuring that Saturn's halo remains a breathtaking spectacle for eons to come. The role of these moons extends beyond mere maintenance. They're essential to the very structure of the rings. The absence of these moons could lead to a more chaotic and less defined ring system, with particles spreading out and potentially colliding more frequently. From a distance, Saturn's atmosphere might appear serene, a pale yellow orb adorned with its iconic rings. But don't let that tranquil facade fool you. Saturn's atmosphere is a complex and dynamic system, filled with swirling clouds, powerful storms, and mysterious phenomena that continue to baffle scientists. But what exactly is Saturn's atmosphere made of? Primarily, Saturn's atmosphere is composed of hydrogen and helium, much like the Sun. Hydrogen makes up about 96% of the atmosphere, while helium accounts for roughly 3%. The remaining 1% is made up of trace gases like methane, ammonia, and water vapor. These trace gases, though present in small amounts, play a crucial role in the planet's weather patterns and cloud formations. If we could descend through Saturn's atmosphere, we'd encounter several distinct cloud layers. The uppermost layer is composed of ammonia clouds, which gives Saturn its pale yellow hue. Beneath that, we find a layer of ammonium hydrosulfide clouds. Even deeper, we find a layer of water clouds, where the pressure is so immense that water exists in a state far denser than we experience on Earth. As we continue to descend, the pressure and temperature increase dramatically, creating an environment vastly different from anything on Earth. One of the most fascinating features of Saturn's atmosphere is its weather. The planet is home to some of the most intense storms in the solar system. Winds on Saturn can reach speeds of up to 1,800 kilometers per hour, or 1,100 miles per hour, more than twice the speed of Earth's most powerful hurricanes. These winds, combined with the planet's rapid rotation, create large-scale patterns in the atmosphere, leading to some truly spectacular phenomena. Among these, the most famous is the hexagonal storm at Saturn's North Pole, a mysterious six-sided jet stream that has puzzled scientists since it was first discovered. This massive storm, large enough to fit two Earths inside, has been raging for decades, and its precise cause remains one of Saturn's greatest mysteries. Advanced models suggest Saturn's hexagon forms from converging jet streams, creating a stable, self-perpetuating system with high-speed winds and seasonal color changes. Cassini's data revealed the hexagon's deep vertical structure and seasonal changes, but many questions about its formation and stability remain. But the hexagon isn't Saturn's only atmospheric marvel. Periodically, Saturn experiences what's known as the Great White Spot, a massive storm system that appears roughly once every Saturnian year, about 30 Earth years. These storms can grow to envelop the entire planet, creating bright, turbulent bands in the atmosphere that can last for months. But the atmosphere isn't just a backdrop for storms. It plays a crucial role in shaping the planet's overall appearance and even interacts with Saturn's magnetic field to create stunning auroras at the poles. Despite decades of observation and study, Saturn's atmosphere continues to surprise and intrigue scientists. The intricate interplay of its atmospheric layers, the dynamics of its jet streams, and the formation of its colossal storms are still not fully understood. One of the most enduring mysteries is the source of Saturn's internal heat. The planet radiates more energy into space than it receives from the Sun, suggesting an internal source of energy. Scientists believe this internal heat is generated by the slow gravitational compression of the planet's core, known as Kelvin-Helmholtz contraction. However, some theories propose an additional process, helium rain. In this scenario, helium condenses into droplets in the upper layers of Saturn's atmosphere and falls towards the core. As these droplets descend, they release heat, contributing to the excess energy that Saturn emits. While this theory is compelling, the exact mechanisms are still being investigated, and it's possible that multiple factors contribute to Saturn's mysterious warmth. But the mysteries don't end there. Saturn's jet streams, which create the planet's distinct bands and stripes, behave in ways that defy easy explanation. Unlike on Earth, where jet streams are driven by temperature differences, Saturn's jet streams may be influenced by deeper, unseen forces within the planet. Additionally, variations in the composition and coloration of Saturn's clouds raise questions about the chemical processes occurring in the planet's upper atmosphere. As we continue to explore this enigmatic gas giant, we can expect even more surprises and discoveries that will deepen our understanding of the universe. Saturn boasts a stunning collection of 146 moons, more than any other planet in our solar system. This diverse family ranges from tiny moonlets to the giant Titan, each contributing uniquely to Saturn's environment and our understanding of celestial bodies. Titan, Saturn's largest moon, features a thick atmosphere rich in nitrogen and lakes of liquid methane and ethane. Beneath its icy crust, a possible subsurface ocean might harbor conditions similar to early Earth, making Titan a prime candidate in the search for extraterrestrial life. Enceladus, though smaller, is equally intriguing with its subsurface ocean and geysers that eject water vapor and organic compounds. These plumes suggest the moon could support life, especially given the potential hydrothermal activity on its ocean floor. Other moons, like Mimas, Iapetus, and Hyperion, each offer unique geological features and insights into the solar system's formation. Mimas is notable for its large impact crater, giving it a resemblance to the Death Star. Iapetus is famous for its dramatic two-tone coloration, while Hyperion's sponge-like appearance and chaotic rotation make it stand out. Saturn's moons not only enhance our understanding of the planet but also provide valuable clues about the formation and evolution of planetary systems. Our fascination with Saturn dates back centuries, with early astronomers marveling at its distant, ringed presence. The space age allowed us to unravel its secrets. In 1979, Pioneer 11 made its historic flyby, providing the first close-up images of Saturn. This mission was followed by Voyager 1 and Voyager 2, launched in 1977 and arriving at Saturn in 1980 and 1981 respectively. These missions offered fleeting but tantalizing glimpses of Saturn's rings, atmosphere, and moons. Imagine the excitement as the first close-up images of Saturn's rings arrived on Earth. The Voyager missions revolutionized our understanding of Saturn. They revealed the intricate structure of the rings, discovered new moons, and detailed Saturn's atmosphere. In 1997, NASA and the European Space Agency launched Cassini-Huygens to Saturn. It carried the hopes and dreams of scientists and space enthusiasts. Cassini-Huygens became one of the most successful planetary missions. In 2004, it approached Saturn, ready to unveil its mysteries. Its instruments studied Saturn's rings, moons, atmosphere, and magnetic field. Over 13 years, it transformed our understanding of Saturn. It discovered geysers on Enceladus and the hexagonal storm at Saturn's North Pole. The Huygens probe landed on Titan in 2005, providing the first images of Titan's surface. Cassini-Huygens inspired with its stunning images and discoveries, showcasing the power of international collaboration in space exploration. Its mission concluded in 2017 with Cassini's intentional dive into Saturn's atmosphere, marking the end of an era but not the end of our quest. Today, telescopes on Earth and in space continue to monitor Saturn, and future missions are already being planned to further explore its mysteries. The scientific community, inspired by Cassini-Huygens, is developing proposals for future missions to Saturn and its moons. One major upcoming mission is the Titan Saturn System Mission, TSSM. This proposed mission aims to deploy an orbiter and a lander, specifically designed to explore Titan's complex atmosphere and surface. The orbiter would study Titan's methane lakes, its thick atmosphere, and potential subsurface ocean. By analyzing these features, scientists hope to gain insights into prebiotic chemistry and assess Titan's potential for supporting life. Currently, in the conceptual phase, TSSM is under consideration for a launch in the 2030s, pending further development and funding. Another noteworthy mission in development is the Enceladus Life Finder, ELF. This mission is focused on studying the geysers that erupt from Enceladus's surface. By analyzing the water vapor and organic molecules in these plumes, ELF aims to understand the composition of Enceladus's subsurface ocean and evaluate its potential to harbor life. The ELF mission is still in the planning and proposal stage, with potential launch dates projected for the late 2020s or early 2030s. Scheduled to launch in 2034, NASA's Dragonfly mission will send a rotorcraft lander to Titan. It aims to fly to various locations on Titan's surface, including its lakes and seas, to study its chemistry and potential habitability. Dragonfly's unique flying capability will allow it to explore diverse environments on Titan, providing valuable insights into its geology and potential for life. The ESA's Cassini-Huygens successor mission's object is to study Saturn's rings and moons in greater detail, potentially using advanced technology to improve our understanding of their dynamics and composition. No specific launch dates have been set, but these missions are envisioned for the 2040s and beyond, contingent on technological advancements and funding. A successor mission could continue to build on the discoveries made by Cassini, exploring new scientific questions and expanding our knowledge of Saturn's system. From its majestic rings, crafted from countless icy particles, to the hidden oceans of its moons, Saturn stands as a testament to the universe's boundless capacity for wonder. Through the hazy atmosphere of a moon with methane rivers, and over the icy plains of a world that might harbor life, the universe is full of surprises, of worlds beyond our wildest imaginations. That wraps up our journey through the wonders of Saturn. From its iconic rings to its mysterious moons, Saturn truly is a world full of surprises. If you could visit one of Saturn's moons, which one would you choose and why? Let me know in the comments below. If you enjoyed this video, make sure to give it a thumbs up and don't forget to subscribe for more cosmic explorations. And don't go far, next time we'll be exploring the icy, tilted world of Uranus. What secrets does this often overlooked planet hold? Hit the notification bell so you don't miss out on the next chapter of our solar system's wonders. Thank you for watching. Until next time, keep looking up.